The next thing we're going to look at is retrosynthesis, Claisen condensation reactions. So this type of question is giving you one of these products, this dicarbonyl, and it's asking if you want to do a Claisen condensation to make this particular molecule, what esters would you need to react together to make this molecule? How would we go about doing this? And for the retrosynthesis of this type of molecule, I really think that the easiest way to do this, to approach this, is by using a trick. It's one of those reactions that we could draw the mechanism backwards. We could certainly do that, and we would end up with the correct reactants. But it's very hard to do, and it's very easy to make a mistake. So for this type of retrosynthesis, I think it's easier to use, like I said, to use a trick. And the trick that I'm going to teach you, first of all, you have to remember that this product, this molecule right here, is a combination of two esters. They might be identical to each other. They might be different from each other. We haven't talked about crossed Claisen reaction yet, but that's definitely possible. So either way, it's two esters that have been reacted together. And when we do the Claisen condensation, when we react two esters together, one of the esters stays pretty well intact. The other ester just loses its OR group. So when we're looking at the product here, the product contains one complete ester and one basically half of an ester. So what you're going to do is start at the end of the molecule that has the ester functional group on it, which is this end right here. All of this. We're going to start there, and we're going to follow away from this ester functional group. So we're going to go down this way. We're just going to carry on. And when we come to a point where we have to make a decision, like where we are right now, do we continue to the next carbonyl group, or do we continue away down a different path? When we come to that point where we have to make a decision, we will continue away from the carbonyl group because we will remember that this is a combination of two esters. We only want one carbonyl group in our final product. So what we get is something that looks like this, and that, what we highlighted, is one of the esters that is used to make this product. And I'm just, redrawing it exactly the way that it is in that molecule, same bond angles and everything. The other portion of the molecule comes from the second ester. And that second ester has an OR group on it, and it lost its OR group in the process of the reaction. It really doesn't matter what this OR group is at all. It could be anything, because it's whatever it is, it's going away. Typically, that OR group is going to match the OR group of the other ester. So normally, we would see these OR groups matching each other. That's standard, but it's not necessary because, like I said, that OR group goes away. We also want to think about what do we have to react, or what kind of reagents do we have to use to make this reaction successful. And remember, this is always going to be a step 2 with acid. In the step 1, we need an OR group, but we don't just need any OR alkoxide. We need one that matches with our esters. All of those need to be the same. Let's try the next example here. So we're going to start with the OR group. I'm going to select that with the esters OR group. And we want to follow that carbon chain, stay away from the second carbonyl group. That is not part of the ester. And that, what we've highlighted, is one of the ester molecules. So let's redraw that guy like that. The remaining portion of the molecule is our second ester. So let's draw it, but it needs to have an OR group put on it. And again, we could put anything we wanted out here, but normally it's going to match the OR group of the other ester. Now we need to choose the correct reagents. We need an alkoxide, And we definitely want the OR group to match. So we want all 3 of these OR groups to match. And then our step 2 is going to be H3O+.